let me come to the very commonly used chart, that is mean or X-bar chart. So, a mean control chart is often referred to as an X-bar chart. It is used to monitor the changes in the mean of a process. Mean we can take only when the data is continuous, that I have said that. So, it will plot the X-bar chart specifically. So, to construct a mean chart, we first need to construct the center line of the chart. To do this, we take multiple samples, compute their means. Usually these samples are small with about 4 or 5 observations. Then each sample has its own mean. So, these mean if a center line of the chart is then computed as mean of all the k samples when the k is the number of samples. So, I will take an example to explain this. So, what we do here, we will have a data something like this. This is sample size, and let me say this is 1, 2, 3, 4, 5 units per sample, okay, and this is number of samples that I have said. If I have taken k samples, I will just putting number 1, 2, 3, 4, 5, and let me say I have picked 6 samples, and each sample is having 5 observations in it. So, I will take this mean x1 bar, x2 bar, x3 bar, x4 bar, x5 bar, and x6 bar. This mean is taken, then the overall mean, which I call it x double bar, is the mean of all the values or mean of these x bars. Okay. This might be put as a center line if it is not given. So, in case of X bar chart, so this x double bar is equal to x1 bar plus x2 bar plus x3 bar, will have up till xk bar divided by k. So, this is our center line. So, to construct the upper control limit, the upper control limit, that would be equal to x double bar, as I said before, plus z into sigma for x for the sample, and lower control limit that is equal to x double bar minus normal deviate z into sigma of x. This value of z is generally taken as 3. So, we can take any value of that. For instance, we need to see that what is the confidence level, what is the significance level that we need to, we are trying to work on. For instance, for z is equal to 2, what would the value? Z is equal to 2 implies the 95.4% confidence level. Okay. Confidence level. Then, if this value is 3, this will be equal to, what is the value? 99.7% of confidence level, right. So, here sigma x is standard deviation of the distribution of sample means. Sigma x, it can be calculated from the standard deviation of the population as sigma by under root n. So, if the process, if the population standard deviation is given, then we can calculate it like this. Here n is our sample size. Okay. So, we can calculate this, the upper control limit, I will put it UCL, okay, then LCL, and we can try to plot the chart. So, this is one of the charts that I picked from the Minitab software. Minitab data, the help files are there, and I have just picked a chart to just show that how the X bar chart is plotted, how it looks like. So, we have the center line, upper control limit and lower control limit. Here they have picked the values has these values as plus 3 sigma and this is minus 3 sigma. Okay. But we will talk about the process capability. We can even pick some other values. In actual working, these limits, sometimes these limits are not specifically 3 sigma. This can be 3.14 sigma, minus 3.25 sigma. So, these limits are defined all. You know, it is a kind of a normal distribution here. This is a kind of a normal distribution here. So, I have put some skewed distribution here. So, it is kind of a distribution here. Okay. So, when we will talk about process capability, we will have more details on this. So, this is the process, we can see the whole process, all the 19 samples that we have taken, they are within control. Okay. They are within control limit, that is the upper control limit and lower control limit. So, next is the range chart. I will now explain the range chart, then I will pick a data and try to plot both the X bar chart and the range chart using Excel sheets. Range charts are another type of control charts for variables. X bar chart measure the shift in the central tendency of the process. Range chart monitor the dispersion or variability of the process. Okay. As I said before, so the method of developing and using Rchart is same as that of X bar chart. The central line of the control chart is the average range and the upper and lower control limits are computed using tabulated constants, and the central control limit is just the R bar. Okay. So, upper control limit and lower control limit is equal to D4 into R bar and D3 into R bar. So, what are these D3 and D4? These are the values which are obtained from the table of control charts. In the table of control chart, I have also put it here. So, this is the value of D3 and Rchart. This is the Rchart's constants. This is for sigma estimate. I will just let you know what is this thing. Also, we can use the A2 and A3 like plus X double bar plus A2 X double bar minus A2 to find the control limits. So, these are the some standard values which are obtained. So, these constants are often used in practice to calculate the value of the standard deviation for the sample. So, these help to speed up the process. So, we do not have to calculate. So, these constants are developed and we can just speed up the process. Okay. So, I have this numerical problem here. In an experiment, the temperatures of the surface of a body were measured in degree centigrade as shown in the following table 15 times at 5 different days. Using the following data, make the X bar and R chart. So, this is the temperature. Temperature, as I said, is a continuous data in this case. So, we can, this is a control chart for variables that we will construct here, and this is taken for 15 times, that is our K is equal to 15 and sample size at 5 different days, 5 different date is taken and sample size is 5. Okay. How could we proceed to do the calculations? First of all, we will calculate the X bar, we will calculate X1 bar, X2 bar, so on. Okay. The average of these values 33, 33.1, 26.4, 28.3, 28.9. So, these X bar would give me X double bar that can be taken as the center line. Okay. So, also I will construct both X bar and R chart. For R chart, I will calculate the range, okay, the lower control limit, then upper control limit for the X bar chart and lower and upper control limits for the R chart and the center lines. So, I will take this data to the Excel sheet and try to plot it. So, this data is produced here in the Excel sheet. So, we have these temperatures at different times in the days. So, First of all, I will try to calculate the x bar, the average of these values. So, this is equal to average of, I can just pick these values like this from B2 to F2, or I can separately even put average B2 comma C2 comma D2 comma E2 and F2, just telling you another way, okay. It will give me the average. So, average of these 5 values is this. Now, I can drag this formula, if you remember this plus sign, this small plus sign. So, you know there were 3 plus signs, actually this small plus sign is the selection of the formula. If I drag, I will drag the formula, okay. This formula is dragged and I have got the x bars. This is x1 bar, x2 bar, 3 bar, 4 bar, so on, okay. These are x bars. Let me calculate x double bar, which is equal to average of all these values. So, this is equal to average of all these values, enter. So, the overall average, which is equal to x double bar, that is equal to 30.39. I will just format, I will just bring it down to the second decimal place, 2 decimals, okay, and let me give it a different color. So, this is my average. Now, this is my, I will put x bar in the next column. I try to calculate the lower control limit, or first I will put the center line, then lower control limit, then upper control limit. So, I will try to put another line here just above this line, insert a line, and I will merge these, and this is my x bar chart, okay. So, center line would be this value x double bar 30/39. So, I will put this value as this is equal to enter. So, this value. Now, if I drag this directly, it will try to pick the values from the elements or from the boxes which are below this. You can see it is trying to pick the value from here. So, that for that purpose I need to lock these values, because I am just picking this one value 30/39. So, this one value I will just lock the row and the column by putting a dollar sign before the column and the row number of this cell. Now, this cell is locked. Now, if I drag this, it will just show the same value, the cell G18. You can see this cell G18 is locked, okay. Here also this cell G, so this is center line. So, next I will try to pick my lower control limit. To pick the lower control limit, I can calculate the sigma value. Another way is I can use the values given in the table that I discussed in this table, okay. So, in this case I like to put another formula, that is a quick formula for the x bar chart. The upper control limit and lower control limit, here the upper control limit and the lower control limit can be calculated using the constants which were tabulated. So, the upper control limit here can be given as x double bar plus A2 into R bar. So, because I need to plot both the charts, I will calculate the R value and then calculate this value. So, x double bar lower control is minus A2 into R bar. So, these constants are connecting the x bar chart to the R chart. So, for that I can first calculate the values for the R chart as well. So, let me calculate, let me pick these columns, merge, I will put here range chart. So, value of R is maximum value minus minimum value. So, this is equal to, I can, because there are only 5 samples, I can just see this is the maximum value, okay, out of the 33, 33.1, 26.4, 28.3 and 28.9, 23.1 is the maximum value, and the minimum value is 26.4, enter. So, range is 6.5. So, I am just observing it manually, but the right way to do it is I can put the formula. I will just put the formula as it is maximum of, this cell would be maximum of these numbers, okay, close the braces, minus minimum of these values again, close the braces and enter. So, it has returned back to this value. So, you can see it is maximum of these values B3 to F3 minus minimum of these values B3 to F3. So, if we have number of values, for instance, if we have 20 values, 100 values, we need to see the things manually here. So, Excel is just helpful in just calculating it, the values. So, the computation is lowered here. So, I can just put the enter, and if I drag this, I will get the ranges. I will just drag it from any point because the formula is same. So, the ranges have come down to these values, maximum of this is 0, this is 0 means two values should be same here, 27.4 and 27.3, oh sorry, maximum is 28.2, no, it should not be 0, escape. Oh, it is some error, I am picking the formula, it has picked the formula for the next row. So, I will just drag the formula from the beginning. Actually, I have started working in a row, in this row 2 here, row 2 here. So, I was working in row 2. I will just now move this data. So, this is the move sign. I move this data here. So, this is my value R, not range chart, this is my value R. Okay. Now, I know my value of the range and lower control limit, as I know I can pick the formula lower control limit is equal to x double bar plus A2 into the range, okay, R bar. R bar would be the average of these values. So, let me put it as this is equal to average of, whatever this is, average of these values, enter. So, format cells, reduce it to the 2 places of decimal, done, okay, 6.2 mine, I will just color it maybe blue, okay. So, this is my R bar only, okay. So, this is my R bar, so my lower control limit would be equal to, as I had put in the formula, this is equal to x double bar plus A2. What is the value of A2? Now, let me come back to this table here. The value of A2, the sample size D1, D2, D3, D4, sample size is 5. So, the value of A2 would be taken for 5 sample size. The value of A2 here is 0.577, if you see. This is sample size is 5, this value is 0.577. So, I will put the value of A2 in my Excel sheet, escape, let me put A2, this is equal to 0.577. Okay. So, this value lower control limit is equal to x double bar minus A2 times R bar, sorry, R bar value is this value, enter. Okay. So, this is the lower control limit. Okay. So, this lower control limit remains the same, x double bar is fixed. So, I will just lock this value by putting dollar signs. Okay. The value of A2 is fixed, the constant A2. So, I am putting dollar signs here. The value of R bar is fixed, I am putting dollar signs again, enter. So, let me convert, okay, this is format cells, 2 places of decimals, okay. So, now if I drag it here, the low control limit is this one. Okay. Similarly, upper control limit would be very similar to this. I will just drag this formula and in place of minus, I will put plus. So, this is my upper control limit. Okay. Now, I have got my center line, my lower control limit and upper control limit for the X bar chart. Now, I can plot my X bar chart using the line diagram that I did in the previous lecture. Okay. So, using the line diagram, I can just plot these 3 lines. So, I will just pick these 3 lines and insert a line diagram. So, it is showing these line diagram, these lower control limit, upper control limit and the center line. Okay. Now, I need to plot my data in here as well. What is the data points? Data points are the X bar. So, if I need to plot these values as well, I will just pick these 4 columns. Okay. I will also pick this title, insert. It has made this control chart. Let me delete the previous one. So, now I can edit this axis to make it look more clear. Format axis, it starts from, it is from, let me say 25, okay, 25 to 37, it is a good range. So, this is okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. About the temperature, at one point temperature taker. So, X bar is given in blue color, which is my variation in the process, and my control limit is in orange color, lower control limit is in the gray color, upper control limit is in the yellow color. So, I have constructed the X bar chart. It is interesting to note here that one of the readings is not in control. So, what do we do here? Whether the reason for this is common or normal, whether this reason is common or whether the reason is assignable, we can see that. So, to see that, we can just once try to eliminate that reading and then plot the chart again. Let me try to do this. So, before that, I will try to put the legend here. Not legend is already there, sorry, I will put the labels here, the data labels, add data labels. So, this value which is out of control is 34.96, which is 8th value. So, 8th value, this is 34.96, this is out of control. If I click here, it will show this value. So, let me try to eliminate this row and then check whether the process is in control, because you know, if I eliminate one reading, X double bar would change, overall R bar would change, the values would change. Okay, but the sample size remains same, that therefore, the value of A2 remains same. So, X double bar and R bar would change overall. So, if I eliminate this value, delete, you have seen that the value has changed to 30.07 and this value is also changed to 6.19. So, these values of X double bar and R bar are changed. So, I have deleted this row. So, now the process, if you can see, the process is within the limits. So, here we can say that this is not a very serious issue. So, we need not to worry, and just by elimination of that one value. So, there is some error that has happened, just because the machine might not have worked properly, or some temperature is not taken properly, the reading is not taken by the observer properly or not noted properly, some error might have occurred. So, the overall process is within control. Okay. So, I will just undo this so as to keep all the values this T8 as well. Okay. This is my X bar chart. Now, let me try to plot the range chart as well. So, what was the formula for range? It was D4, upper control limit is D4 into R bar, lower control limit is D3 into R bar. Okay. So, the value of D4 we need to see for 5 sample size. Okay. The value of D4 and D3. For 5, for sample size 5, the value is for D3 it is 0, for D3 it is 2.11. Okay. So, it is 2.11, let me put it here, D3 and D4, D4 is 2.11 and D3 is 0. I will also put value of A2 here only. Okay. Just a sec please, let me try to show this. This is one block. This is one block and this is one block. So, the R bar value is there, that is our center line. Okay. Then we have upper control limit and lower control limit. Center line is nothing but R bar, this is equal to this cell, enter, I lock it using dollar sign and dollar sign. Okay. Then upper control limit, I better put lower control limit first. I will put upper control limit here. So, lower control limit is D3, value of D3 is this value 0, this is equal to 0 into the R bar, enter. Okay. So, this value I lock everything, actually the value is 0 only, so it would not matter much. So, all the values would be 0 here only, but just to put the formula I am putting it here, I have locked everything. So, this lower control limit is 0 because the value of D3 is 0. The upper control limit is equal to D4, D4 is this value multiplied by the R value, R bar value. Okay. So, I will put the dollar signs here as well. So, I have locked all the rows and columns, enter. So, we have got lower control limit, upper control limit and the values of this center line. So, let me try to plot this. Insert line. Okay. So, this is my R chart and we can see that okay, it hasn't picked the name of the series. So, let me undo and pick it from here. Now, it will show the legend and show the name of the series as well. Insert line. So, this is my R chart. So, I can put here R chart, the name of the chart is R chart and this is my X-barchart. So, I have plotted the Rchart, but as I said before, actually just a sec. Now I will add the data labels as well here. It is showing here. I have put the R charts just like this only to just show whether it is within control or not. But you know, R is the range between within the subgroup or within the this sample that we selected. Okay, sample size is within the subgroup. It is the range. It is better to plot the bar charts to see which bar is the larger. The line, the connection of the lines, because it is the information that is within subgroup. It is subgroup 1, subgroup 2, subgroup 3, subgroup 4. Connection between subgroup 1 and subgroup 2 doesn't mean a great thing here. So, to see the actual range, it is better to plot the bar chart. Okay, I will plot the bar chart to see, okay, this is range. Now, it is showing that the range is minimum in the 15th subgroup, that is the last one, okay, and range is maximum or very close to the two can be comparable, the 6th and the 10th. You know, this chart, that is why I was telling that in data visualization it is very important to select the chart properly, which chart we need to plot, which chart we need to select to plot the data, because we need to see the maximum and the minimum range within the subgroup. So, this bar chart is trying us the size of the or the length of the bar is giving us the feel that which is having a big range. So, there might be we can work on this as well. Okay, these 2 points, there is these 2 subgroups 6 and 9. The values for the T6 is 9.6 and value for T9 is 9.7. The range is big here. Okay. So, this was the control charts for variables. Next, I will try to continue this lecture. I will just have a break here and I like to continue this lecture. I will try to plot the control chart for attributes in the next part, okay, using the Excel sheet only. So, let us meet in the next part. Thank you.